Okay, so looking at lesson 6 and 7, we're going to talk about the other two classes we haven't really addressed much. So we have synthesis, I should say the other three, synthesis, decomposition, and combustion. So synthesis and decomposition reactions, if you don't see something that looks like single replacement, double replacement, or combustion, you're looking at one of these two. I think decomposition reactions are the easiest to identify. You only have one reactant. It's the only type that has one. When these things decompose, they're going to decompose into their elements, basically. So they're going to be pretty easy to write. So we've got mercury here and oxygen involved in the compound. So we're going to form, big surprise here, mercury and oxygen. Just know that oxygen is written as O2. We will get there. We did not cover that yet. Okay. So if we go ahead and write this out, we did that, but we need to balance it. So 2's in front. All right. So we've got potassium and chlorine. Potassium is going to separate, and so will chlorine. Chlorine is also going to be written with a 2 in front of it. They come in pairs. We will get there again. So that's all you need to do there. Just break them up into their elements. All right, now the next thing here. So when we look at lithium and oxygen, those two are going to come together. We know it's not decomposition because there's not just one reactant. So it means the opposite is going to be true. They're going to come form one thing. So we've got lithium coming together with oxygen, meaning it's going to be Li2O, meaning we might need to balance it here. Okay. And then carbon and oxygen are going to come together forming CO2. Pretty easy. All right, so when we look here, this breaking down, because we only have one reactant, it has to be decomposition. So we've got potassium. This one's going to actually be a little tricky. So you would think it's just potassium by itself, but we're looking at potassium oxide plus CO2. One thing I'm going to tell you, if you see CO3 carbonate, one product is CO2. CO2, okay, so carbon dioxide. The other one's going to have what's left. All right, so that's going to be that reaction, and that one's already balanced. All right, so if we look at a combustion reaction, so combustion reactions always have carbon dioxide and water as the products. You're always going to see oxygen as a reactant, and the other reactant's just going to be made up of carbon and hydrogen. So the tricky thing about these is to balance them, okay? You will always write out their products will always be the same. You're always going to have CO2 and water. Balancing's tricky. This one is a balancing challenge, so if you want one, you can do that one later. We're going to start with 3. 3 is actually the easiest one here to balance. The bigger this value is, the harder it's going to be to balance. So there's only 1 carbon and 4 hydrogens here, so that's why I know this one's going to be the easiest. So we're going to go ahead and balance this. So I'm going to start with the carbons, 1 and 1, that looks okay. 4 hydrogens, 2. I'm going to try to fix that with the 2 here. Keep moving. I'm going to do oxygens last. I think that's the easiest way of doing these problems. So I've got 2 here. On this side, I've got 2 plus 2 is 4. It means I needed 2 right here. And that's it. All right, let's try this last one here. So C2H6 plus O2. So CO2 and water are always your products. Start with the carbons. 2 here, 1 here. Try a 2 there. 6 here. Hydrogens, 2 hydrogens here. Let's try 3. Oxygens, I have 2 on this side, so it needs to be even number on this side. So we've got 4 and 3. That's going to be problematic. Whenever you end up with an odd number here, you're going to have an issue in front of water. When you do, just double this. So instead, I'm going to make this a 6. Now I have 4 plus 6 is 10, which means I can put a 5 there. Okay, the other two are going to be a little trickier on here to balance. So if you balance this one and give it a try, you should get 2, 15, 12, and 6. This one will be 1, 38, 25 in front of carbon dioxide, and 26 in front of water. That one's a balancing challenge here.